So let's go over a little bit about how buffers work. You are familiar with the acid-base equilibrium. HA is in equilibrium with H plus and A minus, or if you add the water in, HA plus water gives you hydronium and the conjugate base. So the buffer is primarily looking at the conjugates. And this equation, the Henderson-Hasselbalch equation, helps us find the pH. So really, all we have to look at is what's going on with the two conjugates. So when you add a strong base, the system will buffer the pH to handle that strong base. And the way it does that is the strong base will react with the weak conjugate acid. So if we add something like sodium hydroxide, the weak acid will react with it. And in the process of that reaction, the conjugate is produced. So in terms of our buffer, we have HA and A minus. So we start with some amount, and we would need to be in moles. So if you're given concentrations, you could convert to moles. You're given some amount of each one to establish your buffer. Well, when you add a strong base to the system, it's going to use up your HA, and in the process, it's going to make that same amount of the conjugate. And by base, I mean the number of moles of the base you added. So you would subtract that from HA, and it's forming A minus in the process. So then you get your new amounts, and you can plug them in to see what your new pH is. The same thing if you add a strong acid, except the strong acid will react with the conjugate base. So in your buffer, you have HA and A minus. So if you add the acid, the base has to take care of it. So when you do strong acid, and you're starting with your buffer, you have some amount of HA in your buffer, and you have some amount of A minus in your buffer. When you add the strong acid, it is going to react with the conjugate base. And in the process, it makes more of the conjugate acid. And it's a one-to-one reaction, so that's why you would subtract that number of moles from the conjugate base and add it to the weak acid. And then you can get your new amounts, plug it into the Henderson-Hasselbalch equation, and get the new pH.